Hi everyone, welcome to Vocal Academy. See this problem. Here one circuit given here. So in that circuit, one current source was parallel with two branches. So in one branch there is one resistor is there. In another branch there is resistor, inductor, capacitance is there. So here mentioned that how to solve this circuit means how to calculate current I by using source transformation. So generally we are doing that. So for this we'll find the impedance. And here current I, and for this branch we will get one impedance. So by applying current division rule we will get current in this branch. But here mentioned that source transformation, how to find it. So this is the general method. In both methods we need to convert the overall circuit into frequency domain first of all. So here resistance is 5 ohms given. So for resistance the impedance is R only. For capacitance the impedance is 1 by SC. For inductor the impedance is SL. See here Z is R nothing but 5 ohms only. Keep 5 ohms for resistor. This is impedance of resistor. Here 3 ohms is the impedance of resistor. Now for inductor here 5 millihenry is there. Now apply here S into L is 5 milli. 5 into 10 power minus 3. S means J omega. So here omega is 200 T. So omega into T, nothing but omega is 200. So that is, here write 200 rightly. 200 into 5 milli, that is 5 into 10 power minus 3. Here 205 nothing but 1000, that is 10 cube. So J into 10 cube into 10 power minus 3, nothing but J. So this is the impedance of inductor. Next find impedance of capacitance, that is for 1 millihenry. Use this formula here. So that is Z equal to 1 by S means J omega. Omega is given as 200. So 200 into, and C is given as 1 millihenry. That is 1 into 10 power minus 3. So by simplifying this we will get minus J5 is the impedance for capacitor, that is minus J5. Now convert source into phasor form. Here amplitude is 8 and phase angle is 30 degrees. Here I am not applying doing like this. Here I am going to apply source transformation. That means here current source is there that was parallel with resistance 5 ohms. Now convert this into voltage. So let's see here. Before going to apply source transformation, I am going to one task for you. So use the now method, that is find the impedance for this branch for the frequency domain data. Next for this branch this is the impedance. Now this is the current source here. So by applying current division rule find the impedance in this branch. Then comment your answer in the comment box. Now come to how to apply source transformation here. So this is the general rule. So whenever any current source was in parallel with a resistor, so that can be converted be like this as a voltage source. Make current to voltage source be like this and voltage to current be like this. Let's see here. Here this current source is parallel with a resistor like this. Now I am going to replace this branch, these two branches with voltage source with resistor R. So here this is the format. So here R resistance R is there and current I is there. Now what to take here voltage and what is this resistance value. So keep R value as is, no change. Now according to Ohm's law we know that V equal to IR. So this I product with this resistance will give voltage V here. Now replace the circuit with this branch. So it becomes resistance with voltage source. Now keep remaining branch as it is, no change here. So this is resistance, inductor and a capacitance area. So this is the fixed branch, there is no change, resistance and inductor and capacitor. So this is the source transformation. So by applying source transformation, I converted this current source into voltage source. Now write the data. So here resistance is 3 ohms, and this is J impedance for inductor, and this is minus J5. Now what is the voltage here? So according to Ohm's law, we know that I into R. I is, this is, R is 5. So 8 5s are 40. So 40 with phase angle 30 degrees. R is R only. So keep the distance here. That is 5. Now here the current direction is given as like this towards the inductor. Now we can easily find the current I in this loop. So by finding the overall impedance and having here voltage, so by applying Ohm's law, we will get current, that is V by R. So here impedance is overall impedance, that is Z equal to sum of all impedance values, that is 5 plus 3 8. So 8 plus J plus minus J5, nothing but, so 8 plus minus 4J. So this is the overall impedance for this loop. Now find the current I according to Ohm's law. So that is current I equal to, so observe carefully here, the current direction and the source will be matched, because for the source the current will be moved from positive to negative. So current direction is given in this only. So current I equal to V by R. Suppose if the current direction is given in this format, means opposite direction, at that time take here minus. Here now we don't need minus here, so it was in perfect mode. Now voltage is 40 with phase angle 30, and overall impedance, that is 8 minus 4J. By using calculator, we will get this value in phasor form as I equal to 4.472 with phase angle 56.56 degrees. Now convert into sine form, because here current is in sine. So amplitude is 4.472 and sine of, and here omega is 200t. So omega is 200 into t, and phase angle is plus 56.56. So this is the current, required current for the given problem, and this is the process of simplification by using source transformation. And thanks for watching. Please subscribe, like, share. Thanks.